Alright, here we are on example 3b, where we left off in the notes yesterday. So we're going to go ahead and finish this notes page out. I've already completed 3b for you. It's very simple to do. To find 3u, all we're doing is taking 3 and distributing it to the two coordinates for u. So we're taking a scalar quantity 3, which scalar just means a single number. Okay, we're taking a scalar quantity 3 and we're distributing it to a vector quantity u. A vector is, of course, going to be an x and a y coordinate. So we're just taking 3, multiplying it by the x coordinate, taking 3, multiplying it by the y coordinate, and then just simplifying. All right, now the reason I already have it written out is just to speed things up a little bit, but I also want to show you the picture of it. The directions asked us to graph it. So my original vector u is just -1, 3. It is this vector right here is vector u. And then vector 3u is in the exact same direction. It's just 3 times bigger. Like literally, it is just 3 times bigger. Okay, so it's in the exact same direction. -3, -9, the exact same direction of -1, 3, but it's just 3 times bigger. So that's all multiplying by a scalar quantity of 3 does, is make the vector 3 times bigger, which means it's 3 times stronger. So as far as making up a real life situation for this, you could just simply say something like, and you can write this out, make up your own situation. Something like, you had puny vector u, and vector u worked out for 5 years in a row and tripled its strength, and it became vector 3u. I mean, that's all you would have to say to make up a real life situation for this. Okay, all right, looking at the next one, I have it worked out for you as well. Now this one's a little bit confusing to some people. All right, because you've got scalar and vector operations happening. We got a scalar operation happening when we're taking 2u. Same thing we just did a second ago. You're just going to take the 2, distribute it to each of the coordinates for u. Okay, so that gave me -2, 6 when I distributed 2 to each of the coordinates for u. And then I'm subtracting vector v. So I just put minus and then wrote down what vector v was, 4, 7. And I didn't do anything to vector v on this second step, just simply carried it down because I was distributing the 2. And then once I get these two vectors, I go ahead and put these two vectors together. Now here's where I'll see some algebra mistakes here. Be careful with this. I'm taking my -2 and subtracting 4. Most people won't mess that up. But I'm taking the 6 and I'm also subtracting the 7. That's where a lot of people goof up. They'll take the negative to the first one, but not to the second one. Well, this negative is like having a -1 out in front. You got to distribute it to both. So I take -2 minus 4, I get my -6 is how I get that. And I take 6 minus 7, I get -1. So this is my resultant vector of 2u minus v. A picture of that would look like this. So I would have, I graphed vector 2u rather than just vector u. Remember, vector 2u was -2, 6. So I graphed that, -2, and then 6 up. There's my 2u. And then I graphed vector v would be over here as 4, 7. Well, it wasn't vector v that we used. It was minus v. So that's like having -v. So -v would just be the opposite direction of that. So that's what I did. I went -4, -7, and graphed minus v, or negative vector v right here. And then when you put these two vectors together, you get the result of -6, -1, which is -6, -1, 2u minus v right here. Now notice vector v is longer than the resultant vector. And vector u is probably a little bit longer as well. So it's kind of strange that it actually compressed. Well, the reason it compressed is because these vectors are kind of working against each other in this case. I mean, if you had somebody pulling with a rope this way and somebody pulling with a rope this way, well, yeah, they're pretty much pulling against each other. So the resultant actually gets shrunk down a little bit on how much force would get pulled into this object. Okay, so if you look back over here on our example 3a, we saw that vector u and vector v, when we put them together, they came up with this resultant vector u plus v, and it got longer. Well, that's because u and v are going generally in the same direction. They're definitely adding to each other's power because they're both heading in an upward direction. Whereas over here, vector 2u and our negative v, they're kind of going against each other, so it compresses the resultant vector a little bit. All right, so there's example 3. We'll move on to example 4 in the next video.